Hello students, welcome to Swapna physics classes. In this lecture, I am going to explain you one more important short answer question for your TS IPE, first year IPE physics exam. And the question is, define the terms momentum and impulse. State and explain the law of conservation of linear momentum. First of all, we are going to define the momentum and impulse. What is momentum? It is the product of momentum is the product of mass and velocity of a body. Mass and velocity of a body. Let us consider a body of mass m which is having a velocity v. Okay, for this mass m, the momentum is equal to momentum p is equal to the product of mass and velocity. Okay, this is known as linear momentum. దీన్ని ఏమంటాం నాన్న మనం లీనియర్ momentum. ఒక ఆబ్జెక్ట్ కి మాస్ m ఉందనుకోండి, అది వెలాసిటీ v తో ట్రావెల్ చేస్తున్నప్పుడు దాని యొక్క మూమెంటం ఏమవుతుంది, మాస్ ఇంటూ వెలాసిటీ అవుతుంది. ఓకేనా. అండ్ కమింగ్ టు ఇంపల్స్. వాట్ ఈస్ అన్ ఇంపల్స్? A large force, just a minute, I will change my color of my pen. A large force acting for a short time, to produce a finite change in momentum. See, force is acting on a body for short time, which produces a change in momentum. Here the momentum will change in direction only. The direction of the momentum changes, but the magnitude remains constant. So what is happening here? The change of momentum is in direction only. The momentum is changing in direction only, but not in magnitude. Magnitude remains constant. And the formula for impulse is denoted with I, which is equal to force into time interval. Okay, this will lead to the change in momentum. Okay, whenever you had applied a force, for example, I'm taking a ball. Here I'm considering a ball, and I had thrown this ball with some force F. What happens? This ball strikes this wall and will bounce back, with the same force but in opposite direction. Here what happening? Here the ball will have some mass m and it is traveling with velocity v, and the initial velocity is v. Okay, vi. I'm taking it as vi, and it is the initial momentum of the ball. And this ball strikes this wall for a short interval of time. చాలా తక్కువ టైం, అంటే ఇది ఈ బాల్ ఏమవుతుంది, ఈ బాల్ తో చాలా తక్కువ టైం కాంటాక్ట్ లో ఉంటుంది, అవునా. ఆఫ్టర్ దట్ వాట్ హ్యాపెన్స్? it will bounce back with some force, and it changes the direction, and therefore the final momentum, what happens to the final momentum? The final momentum will be equal to mass into final velocity minus. Why I had taken here minus and why? Because the direction of momentum is changed. Okay, Therefore the total momentum, here the magnitude is same but the direction is different, therefore the initial momentum is equal to minus of final momentum, therefore this will be equal to pi plus pf, which is equal to 0. Okay, here the momentum is constant, the momentum remains same. Okay, the momentum remains same. Okay, and coming to impulse, the impulse I is equal to force into time t. Okay, we know that the force is equal to mass into acceleration. Force is mass into acceleration from Newton's second law. From Newton's second law. Okay, and what is acceleration? Acceleration is change of velocity with respect to time. Acceleration is equal to initial velocity, final velocity minus initial velocity by time t, change of velocity with respect to time. Therefore the impulse I is equal to mass into acceleration. What is acceleration? V minus u, final velocity minus initial velocity by time t into t. Okay, this t get cancelled, therefore we have mass into velocity minus mass into velocity. This is final velocity, initial velocity. This is nothing but change in momentum. Change in momentum. Okay, whenever a force is acted upon a body for a short interval time, it leads to the change in momentum. Nothing but an impulse. This is about impulse. And coming to the law of conservation of linear momentum. What is law of conservation of linear momentum? Law of conservation of linear momentum. Linear momentum. Okay. ఇప్పటివరకు నా ఛానల్ సబ్స్క్రైబ్ చేసుకోని వాళ్ళు సబ్స్క్రైబ్ చేసుకోండి. ఈ వీడియోలో మీకు ఏ ప్రాబ్లం అనిపించినా కూడా, ఏ డౌట్స్ ఉన్నా కూడా కామెంట్ సెక్షన్లో కామెంట్ చేయండి. ఐ విల్ క్లియర్ all your doubts. I will definitely reply to your comment. Okay, and conservation of linear momentum. I will explain this conservation of linear momentum with two examples. Okay, and first one is the total momentum the total momentum of an isolated system. Isolated system ante enti nana, it is a closed system. Of an isolated system of interacting particles of interacting particles is conserved. Interacting particles ante oka rendu particles, for example I am taking two particles. After colliding ఏమవుతుంది? ఇనిషియల్ momentum, final momentum same ఉంటుంది. Okay, for an isolated system, whenever two bodies collides with each other, okay, the initial momentum will be equals to final momentum. Okay, initial momentum ఏదైతే ఉందో అది ఫైనల్ momentum కి ఈక్వల్ గా ఉంటుంది. అంటే ఇక్కడ momentum చేంజ్ అవ్వట్లేదు ఫర్ అన్ ఐసోలేటెడ్ సిస్టమ్. అంటే ఇవి ఈ టూ పార్టికల్స్ ఇంకా వేరే ఏ పార్టికల్ తో కాంటాక్ట్ లో లేదు. ఓకేనా, there is no external force acting on these two particles. Okay, let us consider two particles and the initial momentum of the particles is PA and PB. Okay, this is particle A, this is particle B. Initially this particle is traveling with the momentum of PA, and this particle is traveling with the momentum of PB. Now, after collision, after collision, what happens? The final momentum of the particles will be PA prime and PB prime. ఏమవుతున్నాయి? ఈ పార్టికల్స్ రెండు కూడా కొలైడ్ అవుతున్నాయి. కొలైడ్ అయిన తర్వాత వీటి యొక్క డైరెక్షన్ చేంజ్ అవుతుంది కదా. వీటి యొక్క డైరెక్షన్ చేంజ్ అయినప్పుడు వాటికి ఉండే మూమెంటం ఏంటి నాన్న? PA prime and PB prime. Okay. Now from impulse formula, I is equal to force into short interval of time. Okay, I'm going to use this formula. Okay, now for particle A, the impulse formula will be written as F into delta T. And see, this particle is moving from this point to this point. That means this particle is moving from position, for example, this is position A, position B. This particle is moving in the direction of A to B. Therefore, the force is taken as FAB. Okay, and for particle B, impulse is written as FBA into delta T. Why I am taking BA here? The force direction is from B to A. The force direction is from B to A. And now for particle A, we know that the impulse is nothing but change of momentum. Momentum is changing after collision and before collision into delta T, which is equal to change of momentum. That is after collision, momentum after collision minus before collision. Momentum before collision minus momentum before collision. Okay, and for particle B, impulse is FBA into delta T, which is equal to PB prime minus PB. Okay, this is before collision, momentum after collision and momentum before collision. Okay, now according to Newton's third law, the force by the particle FAB is equal to the force by the particle BA, but are in opposite direction. Therefore, this FAB is equal to minus of FBA. Okay, this is equation number 1 and this is equation number 2. Now from equations 1 and 2, what is FAB? FAB is PA prime minus PA prime minus PA. Okay, and this will be equal to minus of, what is equation number 2 we have here? PB prime minus PB. See here, we have delta T, right? You just not confused about this. Why? Because ఇక్కడ delta T తో మల్టిప్లై చేసినప్పుడు both sides అది రెండు కూడా క్యాన్సిల్ అయిపోతాయి, అందుకని delta T తీసుకోలేదు. Okay, now what I'm doing, I'm writing the final momentum on one side and initial momentum on another side. Okay, PA prime, I'm bringing this PB prime towards left hand side. We have minus sign here, so it will become plus sign into PB prime. Okay, PA prime plus PB prime equals to minus into minus plus PB. I am bringing this towards right hand side. ఇక్కడ మైనస్ సైన్ ఉంది మనకి, అది కాస్త ప్లస్ సైన్ అవుతుంది PA. ఓకేనా, here the momentum, the final momentum, here the final momentum is equal to, this will be the initial momentum of the particles, right? Initial momentum, they remains constant. The total momentum of the system remains constant. The total momentum of the system remains constant and the system is an isolated system. Here the momentum doesn't change. అంటే ఇనిషియల్లీ ఒక మొమెంటం ఉండి ఫైనల్లీ ఇంకో మొమెంటం లేదు, అవి రెండు కూడా ఈక్వలే. దట్ మీన్స్ హియర్ మొమెంటం ఈజ్ కన్సర్వ్డ్. Momentum is conserved. And I am going to use one more example for understanding this law of conservation of linear momentum. Okay, I am taking the Newton's third law. From Newton's third law, I am going to use Newton's third law. Okay, from Newton's third law, force F is equal to mass into acceleration. Okay, and this will be equal to mass into dv by dt. What is this dv by dt? Nothing but acceleration, since acceleration is equal to change of velocity with respect to time interval, right? Now this will be equal to d by dt into mv. నేను m ఇక్కడ తీసుకొచ్చాను అంతే. And what is this mass into velocity? Mass into velocity is nothing but momentum. Okay, therefore I'm rewriting this equation as dp by dt. Okay, whenever there is no external force acting on the system, whenever there is no external force acting on the system, okay, then the force will be equal to 0. The external force is equal to 0. Now from this equation, this 0 is equal to dp by dt. As we know that from mathematics, if dx by dt is equal to 0, this x is equal to constant. అవునా, కాన్స్టెంట్ అంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఒక కాన్స్టెంట్ వాల్యూ తీసుకున్నాను నేను 2, d by dt of 2 ఏమవుతుంది, 0 అవుతుంది. అంటే ఇది ఏంటి, కాన్స్టెంట్ కదా, ఇది ఈ వాల్యూ కాన్స్టెంట్ తీసుకున్నా కాబట్టి నాకు d by dt of 2 is 0 అయింది, అంతేనా? సో అలాగే ఇక్కడ momentum p is constant. ఓకేనా, కాన్స్టెంట్ అంటే ఏంటి, momentum is conserved అని మీనింగ్. ఓకే, momentum is conserved. Whenever there is no external force acting on a system, then we can say that the momentum remains constant or the momentum is conserved. Okay, this is one more example. And here I will end our lecture. ఇప్పటివరకు నా ఛానల్ సబ్స్క్రైబ్ చేసుకుని వాళ్ళు సబ్స్క్రైబ్ చేసుకోండి, లైక్ చేయండి, maximum number of peopleతో షేర్ చేయండి. ఓకేనా, వెరీ సూన్ I will start our live lectures. Okay.